Welcome to OU 2020 Drillbotics team, consisting of 5 petroleum engineering students, namely Omar, Ducha, Park, Maya, and Rahmat, under the advisory of Dr. Ramadan Ahmed. According to the official guidelines, the challenge this year is emphasized on drilling multiple targets of given coordinates with limited operating range of up to 30-degree vertical inclination, 15-degree change in azimuth, and 10 inches of surface displacement. This calls for greater focus on enhanced modification of the directional drilling bottom hole assembly of our team to accommodate the stated objectives. The figures show the visualization of our rig in full standing position and in folded position. A hinge cantilever derrick configuration allows for rig transportation and fitting through limited areas such as doorways. When fully erected, the rig height is 110 inches with a minimum clearance of 10 feet required to raise the derrick.
A number of sensors are installed on the rig. The sensors are load cell to measure weight on bit, torque, RPM and vibration sensors, laser sensor to measure depth, and flow rate sensor. These are the sensors installed on the surface. Gyroscope, on the other hand, is placed downhole to measure inclination and azimuth. These sensors are connected to the data acquisition device, or DAC, that converts voltage into analog readings that are understandable by the control algorithm. The DAC we are using is USB 6353 by National Instrument. This choice of DAC was made due to its capability to integrate really well with our LabVIEW-based control system and user interface. Any input given to the control system will be converted to voltage and will be passed through a variable frequency drive, or VFD, or a pneumatic converter, which will mechanically control the drilling operations. Ultimately, the drilling operations are being monitored by the sensors and create a closed feedback loop. Last year, OU team encountered difficulty in gathering usable data from the gyroscope because of the noise generated by the intense vibration. To alleviate this issue, we are upgrading our gyroscope, and we also plan to attach a spring in between the gyroscope and the vibrating BHA body. This is intended to damp the vibration and ultimately reduce noise. Both the gyroscope and the transmission cable will be coated with waterproof silicone coating to avoid any water damage. This is a prototype for the Control Graphical User Interface, or GUI, where the drillers can set the inputs as needed. It also allows monitoring drilling parameters and present visual alert had some variables gone beyond a defined threshold. As mentioned previously, this time we put a lot of emphasis on directional drilling. To accommodate this operation, we added several new graphs in the prototype to show the drilling trajectory and the trends of azimuth and inclination with depth.
This is the design of universal joint for rotary durable system. Because this year's assignment is having multiple targets, we determined that RSS would be the best for it. The U-joint is made of fork, nut, bolt, bush, pin, shaft, and band cable, and this is the core part for RSS to control the inclination. Pneumatic piston system will be added to this U-joint to change inclination on phase 2, and proper inclination with corresponding dogleg will be tested as well. Adjustment of azimuth is required as well as inclination, and this is the design of chain system to control azimuth. It is made of inner chain, outer chain, chain path, and 2 sprockets. When one sprocket is rotating, which is connected to our control system using LabVIEW, the other sprocket is rotating, which is connected to our drilling pipe, and it is adjusting the azimuth. Band sub is another feasible design for bottom hole assembly to control inclination. The band motor is connected to the drilling pipe. The combination of band angle, rate on beat, and rate of penetration is controlling the inclination.